Okay. Okay, so let's go ahead and record the problem here. Then this way we can work on the one online. So the amino acid alanine, which has major species in solution, is pH 7, is the zwitterionic form, which of course all amino acids should be zwitterionic, or at least their carboxylic acid and the amine would be, charged at pH 7, which is close to physiological pH, right? But so anyways, carboxylic acid is of course negative. Amino group is of course positive, as you guys probably already realized. Ooh, I forgot to change this back. Okay, there we go. So the carboxylic acid group of alanine has a pK of 3. The amino acid of alanine has a pK of 8. As you can tell from their single-digit accuracy, these are very, very approximated numbers. But it's just a problem to get you thinking, right? So estimate the ratio of the concentration of the neutral amino acid species to the zwitterionic species at pH 7. So what we're looking at here is we're going to look at the ratio of acid to base for both groups. Okay? So basically we have two Henderson-Hasselbalch equations. We have one for the carboxylic acid. And that one is pH equals pKa, so pH is 7 equals pK of 3 plus log of base over acid. Again, you're going to want to label what your base and acid are so you can keep track that this is carboxylic acid in this case. Okay? And so your acid is the COOH, right? Your base is going to be the COO minus. And if you may have realized just now that we've also labeled these as positive, negative and neutral, haven't we? Yeah. So we have two levels of information there for when we want to work this problem. Anyways. And then we'll just solve for that ratio like we did for a bunch of other Henderson-Hasselbalchs. Okay? And so we got a 7 versus 3. 7 minus 3, that gives us 4. We do the antilog, and so that's 10 to the 4th power, right? Okay. So what does that mean? Well, that means we have 10,000 more of the base form, which is the negatively charged form, right? Than the neutral form, which is the COH acid, right? Is that making sense? Okay, so we already have it like half done, haven't we? We didn't even need a calculator or anything. Okay, so we're about halfway done. The next one is going to be for the amino group, right? So again, it's a Henderson-Hasselbalch problem. So we have a pH of 7, pK of 8, we subtract over 8, so we get 7 minus 8, right? That's a negative 1. Okay, so we then do the antilog, so it's 10 to the negative 1, isn't it? Okay, and so 0.1. Right. Now, what does that mean, though? So in this case, we have the base over the acid again, right? But the base for the amine is the neutral group, isn't it? The acid form is going to be the NH4+. That's going to be the positively charged one, isn't it? Is that making sense? Okay. So what we see that is we have 10 times the amount of positive charge as we have neutral, don't we? 1 over 10? Yeah. That making sense? Okay. And so if you take those two numbers, you flip the one that's 10,000 over 1 the other way, because we want the amount that's neutral, right? So we do 1 over 10,000, and that ends up with 10 to the negative 4, right? We do 1 over 10, and that's going to be 10 to the negative 1. We multiply those together, because that's how probabilities work, right? That's how population sizes work. Okay. And so when we multiply 10 to the negative 4 times 10 to the negative 1, that would give us 10 to the negative 5. And that's not quite the right way to state these things in proper scientific notation. We only have one sig fig, so we do scientific notation, 1 times 10 to the negative 5, right? There you go. That makes sense?
So you would just want to manipulate it to where if you were doing like traditional, you just have to the HA was on top.
Yeah, let me go ahead and show you the formulas real quick. I think that might help. Okay, so there's your Henderson-Hasselbalch, right? And it really doesn't matter. You just have to remember it's base over acid, right? And when you do these, I would state what my acid form is and what my base form is. It's less confusing that way. So let's go ahead and do the carboxylic acid first, okay? And we're going to go ahead and rearrange this a bit just to make it easier to look at. So we'll end up with the neutral form on top in both of our Henderson-Hasselbalchs. So in this case, pH equals pKa. Normally it was plus log base over acid, right? Our neutral form is actually the acid. So what we'll do is we'll go minus log. And that's acid over base now. Does that make sense? Okay. And so we go ahead and relabel. Our neutral form, our acid, is COOH, right? And our base form, which is the negatively charged one, is the COO minus. So we've labeled that in our Henderson-Hasselbalch now. We solve 7 minus 3, multiply over the negative, anti-log, 10 to the negative 4, right? Okay, is that okay for so far? Makes sense? Okay, so then we need to do it for the amine part, right? And so, again, we just set up another Henderson-Hasselbalch. We're doing it for the amine now. The amine already is in the proper orientation, isn't it? Okay? So we have our base, which is the amine. That's the neutral one. And so we have the pH, pKa, plus log, the base, which is the NH2 and an amino acid. And then that's the acid form of it, which is NH3 plus. We go ahead and solve. Minus A gives us negative 1. Take the anti-log, that's 10 to the negative 1. Okay. So now we have the ratio of neutral versus negative. We have the ratio of neutral versus positive, right? We're looking at the zwitterion versus the neutral form on both sides, right? So we then need to multiply those together. And so multiply them together, and we get 10 to the negative 5. Okay. And this is how you would state that overall, if you're curious. That would be the mathematical representation of it. Or one form of mathematical representation of it. You could do more. That makes sense? Mm-hmm. Yeah. And the neutral over the charged is composed of 2 parts, right? The amine and the carboxylic acid. And so we just multiply those. That makes sense? You want to go ahead and try it?